we are going to learn what is the algebraic and transcendental equation. So, suppose y equal fx be an equation, y equal fx be an equation. So, how we decide the given equation is either algebraic equation or transcendental equation. So, in a simple language, an algebraic equation is such equation that if we able to write the equation in form of a polynomial. For example, if we write y equal 2x square plus 3x plus 1, then what is the polynomial? Polynomial is a0 x to power n plus a1 xn minus 1 up to an provided an does not equal to 0. Provided a0 does not equal to 0. Then this one is a what? This one is a polynomial of a degree n, provided a0 does not equal to 0. So if we compare this one with this one, so what is the value for a0? a0 is a 2, a1 is a 3, a2 is a what? 1. So what is the degree of this polynomial? Degree of this polynomial is a 2. So if we able to write any given equation, means a given equation in form of a polynomial, then this one is called algebraic equation. Otherwise, this one is a transcendental equation. And how we identified the given equation is a transcendental equation if in any equation there is involvement of a special function, any trigonometric function, for example, sin x, cos x, tan x, or any trigonometric function. Any trigonometric function or any inverse trigonometric function, sin inverse x, cos inverse x, sec inverse x, or logarithmic function, means exponential function, logarithmic function, or any special type of a function. Then we say that equation is a what? That equation is a transcendental equation. For example, fx equal x minus sin x. There is involvement of a special function. So, if there is involvement of a special function, then this equation is called what? This equation is called transcendental equation. Fx equal e to power x. This one is also a transcendental equation. Fx equal sin x minus cos x. This one is also a transcendental equation. So, an algebraic equation, if we able to write in terms of a polynomial having a finite number of terms, then equation is called algebraic equation. If equation have any special function, if there is involvement of a special function, then obviously how many number of terms e to power x, if we expect e to power x, then this one is a what? 1 plus x square upon factorial to how many number of terms? Infinite number of terms. So, in other way, we also able to say that if we categorize algebraic and transcendental equation, in a transcendental equation, in terms of a polynomial, if we try to express in terms of a polynomial, how many number of terms? There is infinite number of terms. So, there is infinite number of terms. Also, there is a difference in terms of a solution. As we know that by the fundamental theorem of algebra, the number of roots of this equation is exactly equal to the degree of that polynomial. What is the degree of this polynomial? Degree of this polynomial is 2. So, exactly there is a 2 root. But in case of a transcendental equation, in case of a transcendental equation, this one is not true because y equal e to power x. What will happen? In case of a y equal e to power x, this one does not equal to 0 for any value of a x. So what will happen? There is a no any solution of this equation. But if we write y equal 1 minus e to power x, then at x equal to 0, what will happen? At x equal to 0, this become y equal 1 minus e to power 0, and this become what? This become 1 minus 1, this one equal to 0. So this transcendental equation have a this solution, means x equal to 0 be the one solution. If we write y equal to sine x, then we know that this one intersect the x-axis how many time? Infinite number of a time. So how many number of solution of this one? This one have a infinite solution, and this one have a, this transcendental equation have a what? One solution, and this one transcendental equation have a what? No solution. So in terms of a solution, what is the difference between algebraic and transcendental equation? In algebraic equation, the number of a solution or number of a roots equal to the exactly the degree of that polynomial. Algebraic equation is also known as a polynomial equation. But in case of a transcendental equation, maybe there is a zero solution, maybe there is a finite number of a solution, maybe there is a infinite number of a solution. Graphically, how we find the solution, and what is the meaning of basically graphical solution of an equation? So if we try to plot an equation in xy coordinate, suppose this one is a y equal fx, so suppose this one is a y equal fx, this one is a y equal fx, this one is a y equal fx, y equal fx, y equal fx. So what is the solution? Obviously the point of intersection with x-axis, this point is a solution. So suppose this one is the origin, and the distance of this one is a what? Distance of this one is alpha. So what is the value at this point? The value at this point is f of alpha, this one equal to c. So what we say that y equal f of alpha equal to 0. In general, y equal f of x equal to 0. So for such values of x which intersect on x-axis is called what? It's called root of or solution of this algebraic or transcendental equation. Now, so this one is a algebraic and transcendental equation. Now, what is the need of our numerical methods? Why we study in presence of analytical methods? Why we study the numerical methods? Means different methods for finding the solution of algebraic and transcendental equation. So, for us, suppose there is a very simple equation. Suppose the roots of any equation is what? x1 equal 2.312 and x2 equal 3.124 and x3 equal 1.345, like this. Suppose any equation have a 3 roots, then obviously this one is a what? This one is a polynomial of a degree 3. And suppose this one form x minus x1 into x minus x2 and x minus x3, this one equal to 0. After simplification of this one, suppose we get a dash x cube plus b dash x square plus c dash x plus d dash equal to 0. So by the analytical method, how we find the solution of an equation? So suppose there is a quadratic equation, then we find suppose there is a quadratic equation ax square plus bx plus c equal to 0, then obviously we know that x equal minus b plus minus under root v square minus 4ac divided by what? Divided by 2a. So there is 2 root minus b plus under root b square minus 4ac upon 2a, and second root is a minus b minus under root b square minus 4ac upon 2a. Suppose this one is a cubic equation, means ax cube plus bx square plus cx plus d equal to 0. Then traditionally what we will do, first we put x equal to x equal to alpha 1, x equal to alpha 2, x equal to alpha 2, and try to find out the one value where this equation become C. Suppose this one is a x equal to alpha, for which we find this equation equal to 0. So what is the reduced form of this equation? In a form of a factor, this becomes x minus alpha, and this one is a what? This one is a quadratic equation. Suppose this one is a what? A dash x square plus b dash x plus c dash. So here x equal to alpha with a 1 root, and by solving this quadratic equation we find the another 2 roots. Now try to think, if the roots are 2.312, 3.124, 1.345. So if we put x equal to, in general we put the integer value. Suppose we put x equal to 1, x equal to 2, x equal to 3. So what do you think about this equation? This equation does not equal to 0 for any integer value, because what is the root? The root is a 1.345, 3.124, 2.312. So what will happen? We unable to find out a point where the value of this equation equal to 0. If we unable to find out the value where the value of the equation equal to 0, then we unable to find out this factor. If we unable to find out this factor, then we unable to factorize this one in this form. This one is a quadratic equation. We unable to factorize this one. If we unable to factorize this one, then we unable to find out the solution. Now, somehow, suppose, so if we try to find out the solution by traditional method. Suppose here we find x1 equal to 1, and x1 next the value of x is a 1.1. Similarly 1.11. How many number between 1 and 1.345? Which one is a what? Which one is our first solution? So there is an infinite number between 1 and 1.345. Infinite real numbers. So by hit and trial methods, by traditional analytical method to find out the one factor, here we perform this this application infinite number of times. So this procedure infinite number of times, not application. This procedure infinite number of times. So not manually, even with the help of a computer, it will take a significant amount of a time to find out a one factor. So almost this one manually impossible to find out one factor. If we unable to find out a factor, then we unable to factorize this one, then we unable to find out the solution of this cubic equation. So try to think, this one is a cubic equation, this one is a polynomial equation, but if this one become a transcendental equation, then it's become very tedious, very typical to find out solution of any algebraic and transcendental equation by by analytical method. That's why there is a need of a numerical method. One another reason why we study the numerical methods means a solution of algebraic and transcendental equation by numerical methods means in the era of computers means most of the computer algorithms work numerically, not analytically. What is the meaning of this one? We able to find out the solution of any algebraic and transcendental equation with the help of a computer numerically, not analytically in general. So this one is one reason why we study the numerical methods, solution of algebraic and transcendental equation by numerical methods. Now, if we try to categorize the numerical methods, so now what is our aim? Our aim is to find out this point. Now, how we find this point? So, what are the some mathematical means a technicality means a technical definition? How we find this point? So, if we closely observe this function, so suppose there is a 2 points. Suppose this one is a point A, and the value of the function at this point, suppose this one is a f of A, and this one is another point B, and the value of the function is a f of B. So, if function fx is continuous on closed interval A, and if there is a 2 points A and B, and f of A into f of B is a less than 0. What is the meaning of this one? At one point, the value of the function is a positive. At another point, the value of the function is negative. So obviously, the multiple of this one, f of A into f of B is a less than 0. So first condition is about to apply any algebraic or any numerical method. First condition is fx must be continuous on a closed interval A, and there exists a 2 point A and B in such a manner the value of the function at one point is positive, at another point negative, greater than 0 and less than 0. Then obviously f of A into f of B is a less than 0. If f of A into f of B is less than 0, then this will ensure that the function means equation will intersect x-axis. Because there is a one point where the value of the function is a negative, another point where the value of the function is positive. So this will ensure that the function intersects the x-axis. But how many times it will intersect? So this one is also one another theorem of algebra. If f of A into f of B is a less than 0, then fx intersect x-axis at least one time. Now what is the meaning of this one? If this one intersect the x-axis at least one point, then between A and B, there exists at least one real root or more than one real root, or odd number of a real root. More than one real root, in other words, maybe the even number of real roots or odd number of real roots. But if this one intersect the x-axis, then obviously there exists either one real root, or odd number of a real root. Now, what is the meaning of this one odd number of real roots? Maybe this one intersect more than one time on a x-axis. For example, suppose here we consider this one is a function, this one is a function, this one is a function, and we take one point here and one point here. So at this point, suppose this one is a and this one is a B. This one is a B. This one is a B. So this one is a B. At this point, obviously this one is a less than 0. At this point, this one is a greater than 0. So how many times this function means of y equal fx intersect the x-axis? This one is a one time, this one is a second time, this one is a third time, this one is a fourth time, and this one is a fifth time. So now here, how many number of roots between A and B? There is a 5 roots, because this function y equal fx intersect this one 5 times on an x-axis. So what do you think about this one? If this one is a polynomial of a degree 2, fx equal x square plus 2x plus 1, then how many times this equation intersect the x-axis? Obviously the degree of this one is a 2, so this one intersect 2 times. Similarly, if there is a polynomial of a degree 4, x4 plus 3x square plus 2x plus 1. So this will intersect the x-axis exactly 4 times. Also, there is a possibility there is a concept of a multiple root. Suppose fx equal what? X minus 2 ka whole square. So at one point there exists 2 roots, and what is the point? X equal 2 with the points. X equal 2 with the points where this equation have 2 roots. So on a single point there exists 2 roots. But in case of a transcendental equation, suppose y equal e to power x, then obviously, as earlier we discussed, in this equation there is no root, so this one does not intersect x-axis at any point. And similarly, if we talk about y equal 1 minus e to power x, then this will intersect the x-axis at x equal to 0. Means there is exactly one root of this transcendental equation. Similarly, we write y equals sin x, and as we know that sin x intersects the x-axis at an infinite number of points. So here we give a brief overview of algebraic and transcendental equation. In general, 2 methods of finding the solution of algebraic and transcendental equation by numerical method. First one is known as bracketing methods. Bracketing method. And second one is iterative methods. Under the bracketing method, there are different methods First one is a bisection method, bisection method, bisection method, bisection method, and next regular falsy method, regular falsy method, regular falsy method, regular falsy method. This one is also known as what? This one is also known as a false position method, false position, false position method, false position methods. There are many more methods means under the bracketing method, but initially we discuss about bisection method and regular falsy method or false position methods. In case of iterative methods, there are several methods, but here we discuss about Newton-Raphson methods. Just we write here means not here. Here we write means there are different methods. First one is a Newton-Raphson method. Newton-Raphson method. Raphson method. Raphson method. Newton-Raphson method. Fixed point method. Fixed point method. Fixed point method. Fixed point method. And another one is a secant method. Secant method. Secant method. Secant method. And fixed point method is also known as a iterative method. Iterative method. Iterative methods. So there are many more methods. Means these are the methods to find out in general means real roots. Also there are some methods like Lin-Baristo methods, Mueller's methods. Lin-Baristo method is used to find out complex roots. Mueller methods is also means to find out real roots as well as complex roots. So first we try to understand what is the bracketing methods and what is the iterative methods. Iterative method, obviously if this one is a bracketing method, then you may say this one is a non-bracketing method. Means iterative method is also known as a what? Non-bracketing method. Non-bracketing method. Non-bracketing method. Non-bracketing method. Non-bracketing methods. Now, what is the meaning of a bracket? So, bracket means we try to find out a lower bound and upper bound. We try to means this one is also a searching method. Means we try to confine our search between two points A and B. So if we find such points means A and B in which the root lie, then such method is called bracketing method. Otherwise, method is called iterative methods. Now we try to understand this concept graphically. Means what is the meaning of a bracketing method, what is the meaning of a non-bracketing method, and what is the meaning of a means non-bracketing method, also known as a iterative method. And one by one we discuss about means bracketing method, means a bisection method. Then we discuss about regular falsy method or false position methods. Then we discuss about Newton-Raphson methods and secant methods, iterative methods. So first we try to understand why this one is called bracketing methods. So in all bracketing methods, so it must be necessary we find a point where the value of the function is negative and one another point where the value of the function is positive. So this one is a suppose A, this one is a what? F of P. This one is a B, this one is a what? F of B. F of B. then obviously here this function y equal fx, is continuous between a and b, and the value of f of a into f of b is less than c. So here we find the bracket, means this one. So what is the meaning of this one? If we find a bracket, meaning of this one, here such space is from 0 to minus infinite to infinite, because root may be any real number. If root may be any real number, then this may exist from minus infinite to infinite, means our search area is a what? Our search area is a minus infinite to infinite, means the root lie between minus infinite to infinite. So if we ensure that there exists a point A where the value of the function is a negative, another point B where the value of the function is positive, then we ensure that there exists a point A and B, there exists at least one real root between A and B. Now what is our aim? Our aim is to find out one, means the first real root. So why this one is called bracketing method? Because here we confine our search within a bracket. Within this bracket means A and B. What is our search reason? Minus infinite to infinite. Now our search reason reduced to A and B, means this one reduced from minus infinite to infinite to A and B, means now this one become A to B. Now our search area from minus infinite to infinite become A to B. Now in case of a non-bracketing method, there is no need to find out such bracket, means we start from any arbitrary points. Suppose this one is a point C, f of C, either in this case this one is greater than 0. So in case of non-bracketing methods, there is no need to find out a lower bracket at which the value of the function is negative, upper bracket at which the value of the function is positive. So this one is a difference between bracketing methods and non-bracketing methods.